Check this.
Okay, welcome back. We're going to pick this up with lesson 8.5, which is the properties of logarithms. Now, we've learned how to graph logarithms. We've solved logarithmic equations. Now we're going to be getting into the things that make logarithms actually useful. Now, one of the big things that we talked about when we were learning about logarithms in the beginning was that they were useful for a question like 10 to the x equals 15, okay? How do you get the x by itself when it's stuck up here in the tower, right? And you can't get it down. And I said to you when I was introducing the lesson that at some point logarithms would help us bring this down so that we could, we could solve for x. If we could bring the x down, then it becomes a solvable equation. And one of the ways we did that was to change this from exponential form, which it's in right now, into logarithmic form by saying, okay, log base 10 of this equals this, right? So what we got was log base 10 of 15 equals x. And now you notice the x is down, it's not up in a tower anymore, and we have x by itself, right? So this might look a little better if you took this and put this on the other side, right? And did that. And now, you know, this thing over here, you can actually do this with a calculator. Log base 10 is something your calculator will do. So basically on your calculator, you just press the LOG button, and whatever LOG of 15 is, that's your answer. So that's one way we can use logarithms to bring the x down, but technically we haven't brought it down. What we did was we just changed this into a logarithmic equation. What I'm going to show you today are properties of logarithms that let you literally bring this down like in one shot, and a whole lot of other things that are going to be useful. So here we go. The first property of logarithms is called the base property of logarithms. This is all about the base, okay? And there's two versions of this. The first version here says if you have a log whose base is this letter b of an exponential that is b to the x, then that whole thing just equals x, all right? So you're saying, all right, what does that mean? Well, to make a long story short, a logarithm has a base, and the base of a logarithm is this little number down here. An exponential, like 5 to the x or something, has a base, and its base is that number down there. So we have here an exponential, which is this thing here, right? And its base is b. We also have a logarithm, and its base is also the same number, b. If the two bases match, the logarithm and the exponential cancel each other out, and all you have left is just this, which is this. So you have to make sure that you have a logarithm whose base is the same as the base of the exponential. For example, we have log base 7 of 7 to the x. Because these two things match, we know this is just plain old x, because all this cancels out. But these two have to match. That's the key thing there. So does this work? How do I know this is true? Well, we can prove this using the definition of a logarithm. Let's go ahead and write this logarithm over here. So log base b of big B to the x equals x. Now remember the way we changed things from logarithmic to exponential. We said we started with the base, right? This to the power of this had to equal that. Well, you can clearly see that's the case. This is b to the power of x equals b to the x, right? So when you write this exponentially, you get b to the x equals b to the x. And that is obviously true. So it works. Log base b of b to the x is x leads to b to the x equals b to the x. So we can prove it, so we know it works. So that's the first thing. We'll do a couple of examples in a moment, but let me go on to the second property of logarithms. Now here we have an exponential, meaning something to a power. We have b to a power, and the power happens to be a logarithm. So we have a base, big B here, base of an exponential, and the exponent happens to be a logarithm that has a base, and that base is also b, same b, base, this time of the log. And very similarly to up here, if the bases match, you can cancel everything out, leave nothing but the x. Well, the same thing is happening here, okay? You have a base of an exponential, you have a base of a logarithm, and since they're the same, all this basically just cancels out, and you just get the x. And we can prove this as well. So here's an exponential, b to the power of something. Well, that something just happens to be log base b of x equals x, right? How do we prove that? Well, we do the circular thing. We say log base this of this has to equal this, right? And what that gives us is log base b of x equals this thing in the circle here, which is also log base b of x. So we know it works. So you can see these definitely work. These two definitions here, they work. And to make a long story short, if the bases are the same in a logarithm here, the base of the logarithm, base of the exponential, everything cancels out, you just get x. And here, if you have a b, which is a base to a power of a logarithm with the same base, they all cancel out, you just get the x. So let's do a couple of examples so you can visually see how these work and be able to identify them when you see them. So these properties of logarithms are all about recognizing situations, recognizing things that you're, I should say, looking for, things that I'm teaching you that you should be looking for. So the first thing you're looking for, this is base property here, is that this number is the same as this number. Okay, when you see that, when you see log base 5 of 5 to a power, well, you know right away that these are all going to cancel out, and your answer here is simply 7. Okay, how about here? Well, this time they're x's, they're letters, it doesn't matter. This is going to be what? Yep, you guessed it, 1.5, okay? Because these match, and these match. That's the base property of logarithms. So like we said up here, as long as the b's match, whatever's up here, whatever the power is, that's your value. So here we have log base 3 of 3, but there's no power up here, right? The power, whatever's up here is supposed to be your answer, but there's nothing up here. Well, if you stop and think about it for a second, yeah, nothing up there means that's a what? Yep, you got it. That's a 1. And if you think about it, yeah, that's just 1 because these match. And there's an invisible 1 there that we don't bother to write, but it's there. How about here? This time we have an exponential. We have 3 to a power of something. And it just so happens that this base is 3. Okay, and the base of this logarithm is also 3. So that means these cancel out. And this is just a 7. And we'll box our answers, I suppose, here and here. And then finally, this last one here, we have this number e. Now, what is e? E is actually, it's like pi. It's a special number that comes up a lot in the natural sciences. So we're going to talk about this natural constant later. But for the time being, just trust me on this. It's a number that, it's not like a letter, it's not a variable. It's not like x that can be anything. It's a specific number, 2.7. Okay? So anyway, we have an e here, 2.71828. We have another e here also. So as long as these are the same, that means these cancel out. And whatever your power is, which in this case happens to be this expression right here, that's going to be your value. So that's going to be x plus 5. So there you go. Power property of logarithms. To make a long story short, if the bases match, then whatever the power is, that's your answer. The bases match, the power is the answer. The bases match, the power is the answer. Here, the bases match. This is not a power, but in this case, it's the argument of the logarithm, right? And same thing here, the argument of the logarithm. Okay, so that's the base property of logarithms. Let's go on to the next thing called the product property of logarithms. Okay, so the product property of logarithms. The best way to explain this is to talk about what happens when you multiply two things of the same base. So let's say you're multiplying x to the 5th times x to the 3rd. What do you do with the powers? What you do with the powers is that you add them, right? Because this is, and this is the way I taught it back in chapter 6, that this is actually 5 x's, right? X times x times x times x, all right? And this is 3 of them. And so how many x's do you have in total? Well, you have 8 of them. So what you get here is 5 plus 3. Not 15, you get that. So when you're multiplying two things of the same base, you add the powers, and you get, in this case, x to the 8th. So what happens, what we're talking about here is that multiplication of the bases leads to adding of the powers, okay? Now, these are exponentials, sort of. Actually, well, exponentials would be if the x was the exponent, but there's still something being taken to an exponent. So for logarithms, we're going to use that same property, but kind of in reverse. And here's what I mean. If you have the log of two things being multiplied, x times y. I'll put a dot here even though I don't have to. X times y. That is the same as having the log of x plus the log of y. Okay? Just like here, multiplication creates an addition situation. Here, multiplication creates an addition situation. Okay, and you can see it up here in the notes. So that's it. That's the product property of logarithms, right? And it's pretty useful, and you're going to do a lot of homework problems tonight where you're going to use it. So here's an example of one of the homework questions. All right, and this might seem a little strange at first, but then when you get used to this, you'll see how this works. Use the fact that log base 4 of 2 is 0.5. to approximate log base 4 of 8. You might say, huh? Well, think about this for a second. They're giving us a value for log base 4 of 2. They're giving us this. Then they're asking us to figure out what this is. And this is not a calculator question, all right? Granted, some calculators can do log base 4, but most can't. Most can only do log base 10 and log base E, which we'll talk about in a couple of sections from now. But here's the thing. We can use this information here to figure out what log base 4 of 8 is. Simple, because 8 is actually 2 to the third power, is it not? So if that's the case, this is log base 4 of 8, the thing we're looking for. That's equal to log base 4 of 2 times 2 times 2. And if that's the case, because 2 times 2 times 2 is 8, this becomes multiplication now. Okay, we factored out the 8, made it 2 times 2 times 2. And now we can use this property up here to say, well, when something times log of something times something becomes log of the first thing plus log of the second thing. Well, here we have 3 things, but it still works. So this is going to be log base 4 of 2 plus log base 4 of another 2 plus log base 4 of another 2. And for each one of these, we have a value. They gave us a value. So this is really 0.5 plus 0.5 plus 0.5. So these are all non-calculator questions because the numbers are simple and you're expected to do this without a calculator. So there you go. So if you go scrambling for a calculator to look for, what is the log base 4 of 8, you're missing the point. The idea is to use the log they gave you to figure out how to do the log they're asking you for. Now, granted, sometimes a number is like 0.5 was easy to add, but here 0.793, you might use a calculator just to do the adding, but the idea is not to have to do that. All right, so let's keep going here. Use the fact that log base 4 of 3 is this decimal right here to approximate log base 4 of 48. Now, this one is not quite as simple because of the fact that 48 is not a power of 3. So before, 2 to the third power gave you 8, but now it's a little more complicated. How can I get from 3 to 48, right? So you think about it for a second. 3 goes into 48 16 times, right? 3 times 16 is 48. So you can take that 48 and make it 3 times 16. Well, that's great for the 3, but I don't have a 16. Until you stop and think about it. Wait a minute. Isn't 16 4 times 4? Yeah. So 48 is 3 times 4 times 4. The log of 48 is the same as the log of 3 plus the log of 4 plus another log of 4. And they all happen to be base 4. Okay, so the key is how do you factor this number so that you can get numbers that you can use. Now, they gave us a value for log base 4 of 3. It's right here. There it is. So we know that this right here is just 0.793. But what are these? Well, you notice that the base matches the other base here. The base of the logarithm matches the base of the number, which is, you might say, well, it's not a base, there's no exponent. Yeah, there's an exponent. We don't write it, but it's a 1. And that's a 1. So if these numbers match, this is now going back to the thing that we did before. If these numbers match, then the value is just the power. So this is actually just plus 1 and plus 1 because this is that and this is this. And we didn't need a calculator after all because this is just 2.793. So keep it in mind that, let me come back up here, that if these two numbers match here, that this is your answer. So when you don't have a power, okay, like that's not there, but these numbers match, that's just going to be a 1. So that's what I did over here. I was looking for anything where, because the base is a 4, anything with a 4 in it would be easy. Just becomes a 1. So I needed to find a combination of 4, which is easy, and 3, which is given. 3s and 4s. Okay, moving on to the next example. This is a solve for x situation here. Now, we learned in the previous section how to solve logarithmic equations, and the way we did it was, if we had 2 logarithms, like for instance log, I'll just make something up here, base 5 of 3x plus 2, and it was set equal to log base 5 of, 10. The idea was if the logs match, then drop the logs, and then you just have this. So this is what we did on our last quiz. Okay, if the logs match, drop the logs. Just like when you have exponentials and you have x to the 2x plus 5 equals x to the, 3. If the bases match, drop the base, Remember that? Actually, now that I think about it, it makes more sense to put, since the x is up here, if we had a 4, for instance. If the bases match, drop the base, right? So this is 2x plus 5, and this is 3, and then you would solve from there. So the idea is the same over here. We have log base 2, log base 2, log base 2. All the logs match. But the problem is we can't just do this. Okay, it only works if you have one log on the left and one log on the right of the equal sign. So what we need to do is find some way to get this down to a single log on the left side, right? If we can get this to be all one log, then we can do what we did before, which is drop the logs. But it has to be a single log, right? So you might say, well, how do we do that? Because the only thing we learned was log of something times something equals log of the first thing plus log of the second thing. Well, you can use this in both directions. You can use this in reverse, meaning this also means that if you have log, these all have to be the same base. So let's say the base is b, same b over here, and same b over here. If you have a log base b of a, some number a, plus log base b of another number, call it b, for instance. Actually, that doesn't work because now you think that these are the same number. So let me use, I don't know, w. Okay. Then that must be what? Yeah, it's log base b of aw. So this is the same thing, just in reverse. So that's what you have here. What you have here is a sum of two logs with the same base, and that means you can go backwards and combine them into a single log, which is going to be log base 2 of 3x times 5, which is 15. Well, let me write it out for you first. 3x times 5. Okay? So that means that this becomes log base 2 of 15x, and this is log base 2 of 45. So you can see if you just dropped the logs before, you were going to get 3x plus 5 equals 45, which is wrong. It's got to be times. So now, down here, that log matches this log, so drop the logs. You have 15x equals 45. Divide both sides by 15, x equals 3, and there it is. There it is, nice and simple. Okay? So we used the product property of logarithms kind of in reverse here, meaning instead of me giving you a product and you turning it into a sum, they gave you a sum and we turned it back into a product, and that's called combining logarithms. So sometimes you have two logarithms, you want to make them into a single logarithm, you can use these properties, and that's why we're learning these properties. There's going to be a different property for subtraction. We'll talk about it tomorrow. In tomorrow's video, rather. Okay, so we're done. So have a good day, and part 2 coming up. Bye.
Check this.